We live in a vast universe filled with trillions of galaxies, each containing hundreds of millions and billions of stars. The cosmos is so vast that it is unlikely that humanity will ever be able to study all of the galaxies. However, with the help of our orbital observatories, we have created star maps and peered into the farthest corners of space. And today, as we venture beyond the visible universe, we use this scientific data. Using star maps, we will chart a course through space and time. We will travel beyond not only our own galaxy but also venture farther than anyone has ever looked before. On our journey, we will see the amazing worlds of our universe. So sit back and relax. We are embarking on a journey beyond the visible universe. But before embarking on such a distant and uncharted space journey, we must know where we are going and where the universe actually ends. When we talk about space, we usually mean the observable universe known as the Hubble volume. This is the space that surrounds the Earth and contains all the galaxies and matter that can be observed using our instruments. As we know, light travels in all directions from its source at a speed of 300,000 kilometers per second in space. Although this is very fast on an earthly scale, on the largest cosmic distances, this speed is not so great. Therefore, any intergalactic distance beyond the Milky Way entails a significant delay in the light reaching Earth. For example, if we turn off the sun like a light switch in our homes, we will only know about it on Earth after 8 minutes. This leads to the fact that the objects we see in space, we see them in the past, which means they are younger. That is why astronomers often use light years as a unit of measurement in their calculations. If a galaxy is located 1 billion light years away from Earth, then we see it as it was 1 billion years ago. In this sense, the edge of the visible universe represents a time barrier, 13.8 billion years old. The Hubble volume contains only galaxies whose light has reached Earth in less than 13.8 billion light years. Thus, we consider that the farther a galaxy is, the younger it is and the closer it is to the birth of the universe. So when we look up at the sky, we are looking into the past, and in a sense, we are time travelers. Astronomers have a saying that a telescope is a time machine, and a telescope like James Webb's is a TARDIS, whose infrared eyes gaze into space deeper than ever before. Throughout its 13.8 billion year life, the universe has expanded, and today we can see evidence of this phenomenon, which is called redshift. Redshift occurs when photons traveling towards Earth experience a decrease in wavelength due to the expansion of space. As space expands, it increases the distances between objects, including light waves traveling over very long distances. This has the effect of coloring the visible spectrum red, hence the term. But this phenomenon also affects all types of electromagnetic radiation and thus serves as confirmation of intergalactic distances. Our Earth is a tiny and indistinguishable particle of the visible space, even compared to the rest of the solar system, not to mention the rest of our native galaxy. The Sun, as a star, is of insignificant size, being one of at least 400 billion stars inhabiting the Milky Way, many of which have their own planetary systems. Our galaxy, in turn, is the second largest in the cluster known as the local group, which includes more than 30 galaxies and about 100 smaller and irregular galaxies. Our local group extends for more than 10 million light years, although its four most significant galaxies are relatively close to each other. In fact, 3 of them are even on a collision course. Astronomers say that this is why we do not notice any redshift until we leave the boundaries of the local group. A local group of galaxies is part of an even larger cluster called the Virgo cluster. This cluster represents a denser structure containing about 1.5 thousand galaxies and is the closest galaxy cluster to us. Here, not far from the center, is perhaps the largest galaxy in the entire Virgo cluster, the M87 galaxy. This large galaxy is home to almost 1 trillion stars, and its size is approximately 490,000 light-years in diameter. At the center of M87, a huge supermassive heart rotates, which is a black hole whose mass is more than 6 billion times greater than that of our Sun. This black hole dazzled the world in 2019, becoming the first black hole ever photographed by humanity. It also interests radio astronomers because it emits a high-energy plasma stream that extends almost 1,000 light-years into space. Together with the Virgo clusters surrounding it, this galaxy is part of an even larger cluster called the supercluster of Virgo. This supercluster of Virgo is known to be home to thousands of galaxies scattered across a space exceeding 100 million light-years. However, the scales of clusters do not end there. The supercluster of Virgo is just one of the clusters in an even larger network of galaxies. This cluster of galaxies of a higher order is known as the Laniakea supercluster and includes more than 100,000 galaxies. All of this giant network of galaxies is directed and stretches in one direction, much like how leaves on trees, grass, and all living things on Earth strive towards the sun's light. However, for a long time, humanity did not even suspect anything like this. Astronomers did not know where these and other galaxy clusters were heading. Thus, the movement of this so-called great attractor remained a mystery for a long time. But fortunately, technology does not stand still, and with its help, we can look as far as never before. We have found out that beyond the Great Wall of Sloan, the light delay exceeds 1.5 billion years. From such a distance, we begin to see objects characteristic of a younger universe, thus peering into the past 1.5 billion years. Perhaps here, we can see our own Milky Way galaxy and our neighbor, the Andromeda Galaxy, when they were a bit younger. Both of our galaxies collided with other galaxies, expanded, and grew. These mergers filled the galaxies with building materials of life, gas, and dust, in which new generations of stars were born. At a distance of approximately 8.4 billion years, the universe will look younger and brighter. This is because at such a distance, quasars begin to appear in our field of view. In those distant times, quasars shone throughout the universe like LED lights on a garland around a Christmas tree. At a distance of 8.8 billion light-years from us today, we see a large group of quasars U1.11. Here there are 38 quasars scattered over a distance of 2.2 billion light-years. Not far from this group, there is a second group consisting of 34 quasars and extending more than 2 billion light-years. But then, at approximately the same distance from us, we find one, and perhaps the largest of all groups consisting of 73 quasars scattered across space exceeding 4 billion years. At a distance of 11.2 billion years from today's Earth, we enter the early universe, in the midst of one of the most intense periods in its life. At that time, the rate of star formation in the early universe reached its highest level. Approximately 2.6 billion years after the Big Bang, the universe was dotted with young galaxies that had turned into star factories. Today, these first galaxies are one of the main targets of the James Webb Space Telescope. Among the many reasons that make these galaxies so attractive to astronomers is the concentration of stars and population 3, the first generation of stars in the universe that arose directly from the gas left over after the Big Bang. It was a cosmic dawn, and when these first stars began to illuminate the darkness, it triggered a period that we call the epoch of reionization. In recent years, astronomers have discovered objects at an astonishing distance of more than 13 billion light-years away from today. In the constellation Ursa Major lies the galaxy GNZ11, one of the most distant galaxies made up of ancient stars. It is believed to have formed about 420 million years after the Big Bang. However, GNZ11 didn't hold the title of the most distant galaxy for long. In 2022, astronomers discovered the galaxy HD1, which by some estimates formed only 330 million years after the birth of the universe and 100 million years before the first stars appeared. However, this distance awaits confirmation from the James Webb Space Telescope, which also discovered its own distant galaxy, GLASS Z13, located at 13.5 billion light-years from our time. It is difficult to comprehend such a vast distance, but it becomes even more incomprehensible when considering the expansion of space. So, here, with the light of these first galaxies, our optical understanding of the universe comes to an end. But what lies beyond these limits? After the Big Bang, when the universe cooled down, there were no sources of light, and space was dark. Although in reality, space is not dark, it is colorless and transparent. And this darkness that we see is actually a point in the life of the universe, which arose just a few million years after its birth. And beyond this boundary, no photon has yet reached Earth. Some researchers suggest that this structure may be the one to which all galactic clusters are oriented. Astronomers speculate that this point could be a giant structure where something exploded, and as a result became the center of mass around which the entire universe began to rotate, much like all matter in a galaxy rotates around a black hole. This relic radiation is a childhood photograph of our universe, taken when it was only 379,000 years old. It was at this moment that the optical journey of the high-energy plasma-emitted light began. Then, the very young universe began to rotate under the influence of gravity, and all the photons that appeared were pulled back and absorbed by the incredibly strong gravity. That is why we cannot detect the very first light from the Big Bang today, but only see this microwave background, not light. Other scientists claim that the edge of the universe we observe today is not its actual edge, and most scientists say that beyond the cosmic horizon, there is much more than we can imagine today. But the question of what is actually beyond the horizon of the visible universe remains unanswered. This is what gives our imagination space to roam. In one of the upcoming videos, if you are interested, and if it gets enough views, I will try to dive into the icy darkness of the unseen universe and see what's really there. As for me, I'm off on my next space journey to gather information and create the next exciting space video for you. In the meantime, take care of yourself and your loved ones here on Earth. I want to express my special thanks to everyone who supported me. Without your support, this release might not have been possible. Thank you, friends. And until our next even more interesting meeting, farewell.